In this video tutorial, I will show you how to construct a truth table in the TruthLab, because there are a couple things that are a little tricky until you get used to them. So, the first thing you have to do before you can start is you need to build your truth table. So it says enter an ordering below, then click build or hit enter to submit. So what it wants you to do is it wants you to tell it the atomic formulas in this statement, in the argument. So in this case we have P and Q and R. And we can enter those really in any order we choose, and it will be fine with it. And you hit build. And it fills in the whole truth table for you. Now let me talk about a couple things that don't work. So, clear it. Okay, if you do P, comma, Q, comma, R, it's not going to like it. It says, one of the expressions you entered is not a formula, is what it says. That's not very helpful. But it takes, because you put the commas in, it takes them all as a chunk, but it says, well, but Q isn't one of the, the comma makes it not an expression in our language. You also, if you don't put spaces in between, then it will tell you that you've entered something incorrect. Now, how does it feel about lowercase letters? So if you put spaces in between all of this, it's fine. But let's see how it feels about lowercase letters. Okay, it doesn't like lowercase letters either. Okay, so you have to enter the capital letters. You have to put spaces in between them. In fact, there's actually a little hover text, if you saw that. I don't know how I can make it happen again. Anyway, that's what it wants. Okay, and it fills in all the truth values for you. Now notice it uses lowercase t and lowercase f. I don't like that. You please use capital T and capital F, because lowercase t and lowercase f look a lot alike and they can be kind of confusing. Okay, so then you're going to just click on a space in the truth table, and what it will do is it'll give you the parse tree for that formula with the truth values for that row, for those atomic statements on that row. And what you need to do is chase truth up the parse tree. So if P is true and Q is true, then P and Q is true. And so it'll fill in for all instances where P is true and Q is true. So that saves you a little time. So here now we have true and false. So it's false. Okay. And then click on the next one. So now we have false and true. And also notice that when it's false, it's red under the thing. And when it's true, it's green. So that's also helpful. Let me show you what happens if you do it wrong, because it's helpful to know how to fix it, because it's a little weird. So this should be false, but I'm going to say it's true. And so it says, that's not right. Then it tells me why it's wrong. Now, if I just try to change it to false, it says, since you previously submitted the incorrect truth value for this formula on the assignment, you need to show why it has the truth value it does by selecting the nodes in the tree that determine its truth value. So I'm going to try selecting an F. And now it let me do it, because it was the false on P that made the whole thing false. Presumably if two things made it false, then you could just pick one, is my guess. Okay, so here we go, false and false, so that's false. Okay, now we're going to, it's not P or R. So if P is true, not P is false, and then because R is true, the disjunction is true. See, it filled in the one that had the same truth values. So true, so false. Here we have false and false, so the disjunction is false. And here we have false and true. True and true is true. And finally, false, so true. And true and false is true. Okay. Then finally we need to do the conclusion. And they don't indicate the conclusion with the conclusion symbol. You're just supposed to know it's the conclusion because you can look at the argument over here. I like to put the conclusion symbol there. But anyway, so we have true and true, so it's true. True and false is false. Now you can't, like at this point, you know that everything else on the table is going to work out false because you've taken care of all the cases where it's true and true. But unfortunately, you can't just go ahead and like enter false here. That would be nice, but you can't do it. So you have to do it. It's a little tedious to do it this way sometimes. And we're all done. Okay, so now that we've finished building the table, we have to say whether it's valid or invalid. So we look at all the rows where the conclusion is false. So here we have true false, false true. Okay, that's a false false. So it's invalid. No, sorry, I'm looking for true true false. False 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 is fine. False true, false true, false true. Okay, so they're all fine. So I say it's valid. And it'll tell me if I'm right. And I am, which is good. I sometimes have a hard time reading these falses and trues, so I could have been wrong. Okay, and now if this had been invalid, there would be one more step you'd need to do before the problem would be complete. And that would be to highlight a row that shows a counterexample. So we don't have to do that in this case because there's no counterexample. So we're done. So we get this little helpful message that says, you've completed the problem. And then you know you're done. If you don't see that, look for another step that it's asking for over on the left-hand side.